In last video we discussed about Huygens principle. Now today we will prove the law of reflection from Huygens principle. So law of reflection means the second law, that is the angle I is equal to angle R. This law we are going to prove, okay, using Huygens principle, this one. Now see the diagram. Two incident ray and two refracted rays are considered. Very important, this diagram you must understand this. Incident ray, refracted ray. Though it is not ray, it is wave according to Huygens principle, but since it is difficult to draw the waves and the diagram will not be neat and clean if we draw it like this, so that is why we draw it in the form of ray only, okay. Another incident ray is this one, reflected ray is this one. Now see, if this is the incident ray, if this is the incident ray, this is the reflected ray, the normal will be somewhere here, okay. Angle I will be this one, alright. But here in the diagram this is given angle I. How? That one you remember, how it is angle I. See, we know that angle between two lines is equal to angle between their perpendiculars, right? So you can see from the figure, this line, this base, this is perpendicular to this line, and this small line, this one, this small line, this one is perpendicular to this, okay. So if angle between this and this is I, angle between this small line and the base will also be I, okay. So that is why this angle is drawn as I. At the same time, similarly we can say this angle will be R. Why? Incident ray, reflected ray, if you draw the normal will be like this, okay. This incident ray with normal will make this angle, which should be, okay, not this one, R, no, R will be, this one is normal, reflected ray is this one. So if this is reflected ray, this should be the angle R. Now see, this line is perpendicular to this surface and this line is perpendicular to the small line, okay. So angle between the small one and this base will also be R. That's what is drawn here, okay. Now what is this AB and DC? That is the important thing and which came from Huygens principle. The concept of Huygens principle is here only, okay. See, in last video I told you about wave front. So wave front means it is nothing but the points joining, it is the locus of the points which remain in the same phase. So suppose in this case we don't know where the source is. Suppose the source is somewhere here. From this source we have considered two light waves, this one and this one, okay. Now see, this light wave, incident wave, it has traveled more distance as compared to this, okay, and it is meeting the surface at point C and this one is meeting the surface at point A. Since both are not traveling equal distances, point C and point A will not be in the same phase. Same phase will be it will be shared only by those particles which are equidistant from the source. That means if we draw a perpendicular like this on this line at B point, now see this length of the line and this length are same, okay. I'm just giving one name here. Suppose this is P, this is Q, okay. So as we draw this small line from A on next this incident ray, then what happened is now PA and QB is same, okay. That means in other words, point A and point B are equidistant from the source, and if they are equidistant, they will be equidistant, right, from the source, because PA and QB are same length. So since they are equidistant, point A and point B will be in the same phase, and if they are in the same phase and if you join them, this locus will give us the wave front. Okay, now since this wave front is related to the incident waves, we call it incident wave front. Incident wave front, correct? Similarly, for reflected light, you see that this reflected light has traveled more distance than this. Okay, so as a result, what we do? Again, we will draw this kind of small line here, so that, okay, I am again giving some name, suppose R and S. Okay, so RD and SC will be same. That means D and C will share the same phase, or will have the same phase. If they are in the same phase, this line joining D and C will also represent a wavefront and that wavefront, since it is related to reflected light, reflected wave, we call it reflected wavefront. Okay, so AB is the incident wavefront, DC is the reflected wavefront. A very important thing to remember is that whenever any wave moves between two common wavefront, suppose a number of waves are there which are moving between two common wavefront, then, and if the medium is same, then they will take equal time. That means, okay, suppose if this is a wavefront, this is another wavefront, some waves are moving like this from this wavefront to this wavefront, this one, this one, this one. So all these waves, in provided this whole thing is in the same medium, this wave will, if this wave takes time 2 seconds to move from this wavefront to this wave will also take the same time, 2 seconds. This will also take the same time. So time taken by all the waves moving between two common wavefront will be same. Okay, fine. This concept we are using here. Now see, BC, this part, BC, this line or this wave, isn't it moving between incident wavefront and reflected wavefront? Similarly, this line AD, or this part of the wave AD, that is also moving from incident wavefront to reflected wavefront. That means time taken by AD and time taken by BC will be same to move from incident wavefront to reflected wavefront, and suppose that time is T. Okay, so what is T? T is the time taken by the wavelets. Wavelets is, it is mentioned wavelets because it is originating from this wavefront. We discussed about wavelets earlier, right? So anyways, whether you mention wavelet or not, the fact is that this time from B to C and from A to D, time will be same, which is T. Okay, this one. Now time means we have a formula, S is equal to Vt. So from this, T should be equal to S by V. S means distance by velocity. So that is why for BC, the distance is BC itself. So this will be distance BC by velocity. Similarly, that is equal to, for AD also the distance is AD only. So AD by V. So we can write this equation. Okay. Okay. Therefore, from these two, if you just check, you will understand that BC and AD are same, right? With this V will get cancelled. So BC equals to AD, which is given equation number 1. Next, triangle ACB is considered. ACB. In this triangle, if you consider this angle I, sine I will be equal to, sine I means what? Perpendicular by hypotenuse. So which one will be the perpendicular? BC is the perpendicular, AC is the hypotenuse. So BC by AC, which is equal to sine I. Okay. So from this, BC is equal to AC sine I, equation number 2. Alright. Next, from triangle ACD. ACD. Yeah, this one only, AC and D. So in this triangle, this is the angle. So sine R will be perpendicular by hypotenuse again. Perpendicular is AD, hypotenuse is AC. So AD by AC is sine R. From this, AD is equals to AC sine R, right? Equation 3. Now what we are going to do is, we know BC equals to AD. So in place of BC from equation 1 we can write AC sin I. In place of AD from equation 3 we can write AC sin R. So AC sin I equals to AC sin R. Okay. AC will get cancelled, sin I equals to sin R, or sin get cancelled, we get I equals to R, which is the law of reflection. Okay, so I hope this much is clear. In next video we'll discuss law of refraction using Huygens principle. Thank you.